Welcome to clickmyproject.com. Let us discuss about the diagnosis of Alzheimer disease using EEG signals. Let us discuss about the abstract of the product. So the EEG is an electropsychological monitoring method to record electrical activity of the brain. So the EEG measures voltage fluctuation resulting from ionic current within the neurons of the brain. So in clinical context, EEG refers to the recording of the brain's spontaneous electrical activity over a period of time. So as recorded from multiple electrodes placed on the scalp, EEG is most often used to diagnose epilepsy, which causes abnormalities in the EEG readings, and also it is used to diagnose sleep disorders, coma, encephalography, and brain death also. So EEG used to be a first line method of diagnosis for tumor, strokes, and other focal brain disorders, but this use of cost decreased with the advent of high resolution anatomical imaging techniques such as magnetic resonance imaging, so that is a MRI, and computer tomography CT. So derivatives of the EEG techniques included evoked potential, which involve averaging the EEG activity time log to the presentation of the stimuli of some sort, and also visual stationary of the auditory. So in this proposed work, Alzheimer disease is one of the most common and growing neurological disease in the world. So several brain marks tool exist the diagnosis and disease prognostication of Alzheimer disease, which can be assumed as a key issues of clinical applications. So the EEG signals helps out powerful and relatively cheap tool of diagnosis of different neurological disease. So the need is in this case to improve the diagnosis accuracy of the EEG signal. So in this proposed work, a new methodology of diagnosis of Alzheimer disease using the EEG signal is proposed, so thereby increasing the diagnosis accuracy of EEG signal and the diagnosis. So several features of EEG signal such as spectral features, coherence features, and EEG spectral temporal modulation, energy based features are described in detail. So from the above discussed features available in the EEG signal, it is concluded that EEG can play an important role of diagnosis, dementia, and Alzheimer's disease of the process. Let us discuss about the flow diagram of the process. So this is the overall flow diagram of the process. So the data set of EEG signals has been taken. So select the input signal from the data set. Electroencephalography is an electropsychological monitoring method to record electrical activity of the brain. So first of all, we taken the input signal. It include basics of the EEG, whatever it may be, the EEG signal will be calculated, and then noise filtering. In the noise filtering, here we using the Butterworth filter to denoise the signal. So it includes a noise removal from a raw EEG signal. Basically, pre-processing of EEG signal involves amplification, filtering of signal, and after removal. So to obtain more enhancement EEG signal, various techniques. So that is called a blind source separation. So in the BSS concept, to obtain the more enhanced EEG signal, various techniques are such as BSS, and also independent component analysis, that is ICA, and then time frequency representation. It will be calculated by time frequency representation. Finally, calculating the feature extraction. So in the feature extraction process, we extract the feature by using the mean, standard deviation, and entropy value of the process, and then classification. So in the classification process, we can implement the SVM classifier. So that is a support vector machine to identify the signal as normal or abnormal. So it will be take a disease or non-disease. So support vector machines are based on the concept of decision planes. So define the decision boundaries. A decision plane is one of the separates between a set of objects having a different number of membership. So that is using by the classifier, and then finally getting the output. So the output, it will be a signal, it will be normal or it has an disease. So that will be calculated. So normal or abnormal signal are presented. So what it may be. So the classifier should be output. Finally, calculate the brain tumor or EEG signal. It should be a normal signal, or in case it have a normal signal. So the data set is must. So the data set of EEG signal, the input signal, and then the input signal of the processing. And the pre-processing, here we using the EEG signal. So that is a Butterworth filter to remove the noise, and then blind source separation. So that is a LL, HL, and HL. So these are the basic concepts of the Butterworth and noise filtering of the process. And then feature extraction. To calculating the feature extraction, mean, standard deviation, and then particularly we calculating the analysis of the process, and also calculating the entropy value. So these are the overall flow diagram of the process. Let us discuss about the running procedure for the product. So click the main file and then run. So it will be designed for the guide design of the process. So it's taken some time to display. So that is a guide design of the process. So this is the classification of Alzheimer disease using the EEG signal of the process. So first of all, click the select button, select the signal. So it should be enter the number of signal, whatever it may be. I will choose 15. So enter the signal as 15. So this is the 15th input signal. It will be 15th patient also it will be detected. So whatever it may be, there are a number of signals. I will select the 15th patient EEG signal, and then this is the input signal. It will be displayed, and then pre-processing. So in the pre-processing step, here we using the Butterworth filter. So Butterworth filter, the values it should be applied. So it should be remove the noise and the peak detected. For a basic example, in the select the input signal, I will select the 15. So this is the input signal. It will be the peak is a different variation, and it's also noise also will be displayed. So in the pre-processing step, it will be reduce the noise. So reduce the noise and the peak will be correctly displayed. So only we getting the signal, it should be normal or abnormal. And then features. So in the feature, we can calculate the mean, standard deviation, and then entropy value should be calculated to extract the feature of the process. So all the values that will be wavelet signals like LL, LH, HL and HS. So all the values which will be displayed. So these are the different types of values. So this is a wavelet feature. So up to this, for example, so or LH and then LL value, so and then HL and then HS value. So all the values it will be displayed by the LL, LH, HL and HS of the process. So this is the feature extraction of the process. And then test features. So these are the test features values. So it will be calculated like test features particular of the input signal. So these are the different test values. So only we classify the signal, it should be normal or abnormal of the process. So the test feature is important to calculate the signal, it should be normal or in abnormal condition. And finally classification. The classification process, the signal it should be normal signal or abnormal signal. So I will calculate the signal as normal. So that is no problem in the EEG signal point. So I will calculate the signal, it should be normal of the signal. So and then click OK. So the finally performance analysis. So this is a performance analysis. So this is a number of signals, how many signals are presented, and then these are SNR values, signal to noise ratio, how many values are presented. So finally I will click exist. So all the process will be exit. So and then I will calculate for abnormal signal. So I will again I will select the signal for select the signal number. I will select particular 20. So this is a 20 new signal. So the same process, similar process will be uptime, and then pre-processing the signal by using the Butterworth filter. And then features. So features value I will display LL, LH and HL and HS. So all the values are displayed like whatever it may be. So this is for LL and LH and then other values. So all the values will be calculated by using the extracting of the features. So this and then finally it will be calculated the test features also. So whatever the input signal we will give, and the test feature will be displayed. So the test feature is the sticker sometimes. So this is the test feature for the 20th EEG signal. And then classification. So the signal should be normal or abnormal. I will click the signal should be abnormal signal. So this is the classification process by using the SVM classifier. So finally I get the performance analysis. So performance analysis is the number of gas signals and then SNR values. So these are the overall running procedure for the process.
Thank you for listening this video.